Anybody else, man? Alright, so last week we did intro to basically triangles, right? So what do we do last week? Just so that we know exactly what to do. Types of triangles. Scalene, isosceles, equilateral. Proportionality. Of sides and angles. The right triangles. What do we learn about right triangles? We learn about the areas. SOHCAHTOA, you shouldn't be looking into your book, you'd have studied it. Sine, cosine, tangent. Pythagoras. Pythagoras theorem or Pythagorean theorem. Whichever one you want to learn that, right? And that was a squared equal to b squared plus c squared, where here see a is the hypotenuse. So all the time, the longest side goes here, the two shorter side goes over here and be added, right? What else do we learn? I think that was it for right triangles. We did non-right triangles. What's your name, miss? Teresa. All of these is coming there, right? From Sept, yes. Right? The video is here. Right, non-right triangles. What do we learn in non-right triangle? We learn the area. We learn that area can also be half base times height, just like right triangles. However, height equal perpendicular height to base. Remember that? That's a key. Right? So if we had a triangle like this, the base was 12, this was 5, and this was 6. We couldn't use this to find the area. We would have to know that height, right? And if that was the base. Clear enough? Where this height is perpendicular to the base. That making sense? Cool. What else did we learn? Cosine and sine rule. Cosine and sine rule. Cosine rule. Who can remember what the cosine rule look like? From what they studied 15 times.
A squared equals b squared plus c squared minus.
So in other words, it looked like Pythagoras' theorem first. Then
minus 2.
Whatever is added first, whatever is added last, and then cosine, whatever you started with, but the capital of that. But that's the answer. Right? And you'll see it in the video. What else do we learn? The sine rule. What's the sine rule looking like? We have a couple version, eh? And the flip of it as well. And it's in the video, right? When do we use the cosine rule again?
Sides, we know the first.
I know what you mean, included angle. Yeah. And Good. And when do I use the sine rule? Every other time. All right. What I do there? Huh? Go again? Standard triangle. We started standard triangle. And this is where it's a key start to show it colors. That's all? Standard triangles. What do we start with? The standard triangle.
45 degrees.
45 degrees. 45 degrees standard triangle. Good. And that's where we basically left off. What do we want to do today? We want to revisit standard triangles altogether, right? 45 degrees and 36 degrees, right? And what else do we want to do?
On the radian measure.
We want to do radian measure for sure.
And the graph that pick function.
Graphs of trig ratios or functions, but not only that, and their reciprocal. Let me spell it now. Right? And what did you miss in here? So we can't write incorrect spelling on here. Here now? No. You guys should be able to verify for me, you know, you should not always go to Google. Find out that. Right? C-A-N. C-A-N. All right. And that basically doesn't mean the flip, right? But we'll figure that out. And reciprocal trig functions, or trig ratios, as they like to call them. Why they call ratios? Because as you realize, soccer torque is just sine equal opposite upon hypotenuse. So they're all ratios, fractions. Ratios are fractions. So no. What else was on the list that we didn't complete last week?
I think that's it.
That was it. And then we're going to, so all of these stuff are very, very important for Mr. Kier. You will actually see them. Unlike these, you will only use them throughout the question, in other sense. But they're actually testing these concepts. But you might need to draw on these concepts in order to answer the question this entire. Fair enough?
Sir, how far is that? Like T looking like HM.
Theorem. Oh. That's the abbreviation. A theorem. But because. All right? Cool. That seems okay. So what we're going to do now, we're going to just jump right back into standard triangles. And we're going to start from scratch with the 45 degree standard triangle so we can all follow. Here now.
Before I move on, sir, when do you use the cosine rule? Is it?
Two sides and included angle. What that mean? It means if I label this triangle capital A, capital B, capital C, right? The nomenclature, that's a word that you can meet in the video, means just the science of naming stuff. How do I name this triangle? The opposite side is always letter A. Opposite side of this angle C, that is always denoted by capital letter, is letter C. And that is going to be little b, which is why I said b equals to 12b, right? No. Well, that was really base. It's just coincidence, right? So that b and that. So when we're talking about half base times height, that's a different b I was talking about. Base mean base, b mean base, and this is just the common letter of that. So forgive me for using that same triangle. What do I mean by included angle? I mean, if I use A and C, you see those two sides? The included angle is the one right here, so the one that is formed by the two sides. Right? So that's why I use A and C, or if I use B and C, like in this cosine formula, then the included angle will have to be A, you see?
Right.
Does it work?
Yes.
But if you name the triangle correctly, using opposite sides being common letter of the capital letter, you will always be right on target with that cosine rule. You wouldn't need to consider what is A, what is B, what is included under. The formula will just automatically tell you. Fair enough? That's why it's so important to just start with the correct thing from scratch. That making sense? All right. Another video again, guys. Mostly everybody else, except for Teresa, is supposed to be able to correctly. Even you'd have got the video yesterday. You'd have watched this, right? You'd have gone to bed like 3 o'clock watching all
Not 3
videos. You know?
Watch 2 of them.
All right, good. And the video quality was good. You changed from 720 to 1080.
I think it was 720. It was fine at 720.
Because you have a very expensive computer at home. You know? Because quality not that great. All right. Yeah, so can you erase all of this, right? All of this will be in your circuit, right? What's wrong with this, guys? Beyond that, that's not the problem, right? You will feel by time you need to study by exam. What's wrong with this?
Sorry, I can't see through this.
You just need glasses, thicker glasses. Exam lens already, right? But what is wrong with this? You have the same issue, you know? Yeah, so you can tell me, right? What's wrong with that?
I don't know too many skills.
No! This is not a new book.
I don't know because
Huh?
this is unit 2.
What? What the hell? Alright? So much so that you need a brand new book for module 1 alone. So Saturday, maths class is a separate subject than Sunday maths class, you know?
So I put it in pencils and I rewrite it in a new book.
Okay. That's wrong with that. And you didn't get around to transcribing. You have the new book in your box. You just don't finish transcribing it. All right. I'll leave over one. Whatever you know, right? Okay. Right now, one way going to do today, which is standard triangle, radian measure, graph of trig ratios and their reciprocal trig function, and those things we're leaving it here, right? Let's see how far we get. All right. Ready again. Now, we're going to derive the 45-degree standard triangle again. Just walking through it because in the exam, I would suggest more than that. Just jot down the standard triangle right at the front of the page. That is after the exam, I'll tell you, you may begin writing. If you write before, then come around, you're going to say you bring it in the exam and you fail because you cheat. But you must see that the right thing, so yeah, if you are an advantage in the exam. And you don't want the examiners to see that man, you don't want the examiners to say cheating because of 5 years. That makes no sense. All right. So you don't write anything on your hand, you know, at all. You don't draw anything on your hand, whether I'm related to maths or not. and it's a permanent tattoo, you can prove it. Don't tattoo Pythagoras theorem on your hand. We're clear now? Cool. You'll be permanently excluded from the exam. Clear now? Alright. So, in the standard triangle, 45-degree standard triangle, all standard triangles come from right triangles, right? And what's a right triangle again? Otherwise known as a right angle triangle. What that means? And this third out, I still want that answer. What's a right triangle? Justin.
Right angle is a triangle with a 90-degree angle.
With one of the angles measuring 90 degrees. Right? So just like how I ask stupid questions, I keep me asking stupid questions. I don't expect you to just hold the pen in your hand, not writing in any answer because the question is so stupid. You know? Produce an answer. You know? You get them all. That's all. So I'm going to draw a right triangle first and foremost, right? And then this 90 degree is the right angle. Right opposite to it is the hypotenuse all the time. Why? Because the hypotenuse in our triangle is the longest side. And on the video, you will know that if in our triangle you have an angle, Teresa, that's you are talking to. If the largest angle in the triangle will be opposite to the longest side. It's just because of the proportionality of opposite sides and their angles. Fair enough? So that means the angle that is smallest will be opposite to the shortest side. It just works like that. And if two angles are equal, the sides opposite to them will also be of equal length. Yes? Now, if I tell you that we are constructing this right angle triangle, okay? If I tell you that we are constructing this right triangle with one of the angles being 45 degrees, knowing well, Teresa, the rest of them here last week, that means this is your question. If one of the angles is 45 degrees in our right triangle, what is this other triangle? What is this other angle? Why? Yeah, but I never tell you that I never tell you that they are equal, no. What do you know about angles in a triangle? No. They all add to 180 degrees, right? So angles in a triangle add to 180 degrees. So if one of them is 45, this one is clearly 90, although you was something there, what you see that you know is 90. And I don't know what this is, so this is X, and that is 180 degrees. No? They call them out at 180. For 90 and 45, if you see my maths is good, 135. Yeah? And then X equals 180 minus 135, and in the calculator, you get 45 degrees, right? Now, importantly, when I'm constructing, but it wasn't the rationality here, wasn't the reason for it being 45, right? You have to sit beside mommy, all right? You're going to ask her a question. So this is 45, that's 45, and this is going to be, so we know that the side opposite to that is equal to that. Whatever this is going to be equal to that. Why? Because this angle and that angle are equal, therefore the side opposite to them must be equal. But even before that, when you're studying, you must just study that the standard triangle come from a right isosceles triangle. So you already know that two sides are going to be equal and two angles are going to be equal, right? But one of them is already 90. No, for convenience, we didn't just say, all right, let them be X and X. right? I tried that, I never too, flat. You can derive it with the x and x by rate, right? Now, this is going to be 1 and 1, just for convenience. I just want to assign a number to it, any random number, but I want the simplest number. So I choose 1. 1 is the simplest one, all right? By Pythagoras, I could fill this in. Pythagoras said the hypotenuse that I assign to the x squared is equal to the sum of the squares of the two shorter sides. That's what Pythagoras said. So, therefore, this is x squared equal to 2, x equal to plus or minus root 2, but because lengths can't be negative, we take it to be positive root 2, right? And therefore, we learn that this is root of 2. So that's the standard triangle. For homework, part of the homework, you'd have gotten this. Evaluate what is sine of 45. So if they say find the exact value, so anytime in the exam you see Mr. Kate says here, find the exact value of something, and it's going to be in questions 3 to 4. Why? Because that is where we will have trigonometry. Right? You can also present it in question number 1, right? Because that's what we would have done certs. Anywhere in the exam, you want them to find the exact value, chances are you're going to need to use your standard triangle, especially when it involves sine, cosine, and tangent. Now, sine of 45. Having derived this standard triangle that you have to know, or you have a calculator, the fancy calculator that is one that I recommend. You'll see that in the video. 45 degrees, so I put my hand on 45 degrees. And what is sine? Sine is opposite upon hypotenuse. So that is 1 upon root of 2. Yes? And that will be the exact answer. Unfortunately for you, in Saturday classes, you will learn that this is not a presentable method. You have to rationalize it, whatever that is, right? Which is, we have a certain denominator. That means something with a root that cannot be simplified, right? In class, you're going to learn that you can always do this. So whatever the third is in denominator, I can multiply top and bottom, the numerator and the denominator, by root 2. Look what I effectively multiply by 1. Anything multiplied by 1 is itself. So I never do anything different. So, and then this is root 2 upon root 2 times root 2 equal to 2. And you see that root 2 upon 2 and 1 upon root 2 are the same thing. Yeah? However, that is whichever one you want to write, or sometimes even the multiple choice in Mr. Kate have this, although they tell you that they don't want Sept. Hear that? So recognize both of them. And that this one that you will get on your black Casio will be 0.707, but that's not the exact answer. A decimal is never ever the exact answer. Exact answers include thirds, it means roots, it includes pi, which is the symbol pi. It includes e that you will learn about later on, which is the natural base. It includes ln, which is the natural log, which you're going to learn about later as well. Those are exact numbers. It never ever includes decimals, right? So that's what exact numbers are. It's not rounded, and decimals can be rounded to the nearest tenth, hundredth, thousandth, etc. Right? Cosine of 45 degrees. Cosine is always, well, it's coming from the top, so this is adjacent upon hypotenuse. That means I need to put my hand on one of the 45. Any one of them. If I put my hand on this 45, what would be the adjacent side? Remember that? The adjacent side is what? Sit beside the angle. So it's either the hypotenuse or this side. But the hypotenuse is already the hypotenuse. So this is the adjacent side, 1. And the hypotenuse is always the longest side, which is root 2. You realize that the sine of 45 or the cosine of 45 is exactly equal. Right? So it is also equal to root 2 upon 2. If it is that, that is what, right? Tangent of 45 degrees is equal to, we use torque, opposite upon adjacent. What's the opposite side to a 45? I can put my on this 45. Opposite is 1. Upon adjacent, which is 1. 1 upon 1. If I put mine on this 45, it doesn't matter. Opposite, 1. Adjacent is 1. It doesn't matter which one of the 45 you use to evaluate sine, cosine, and tangent in the 45-degree standard triangle. Right? I did not share the textbook either, no? Said I was going to share the textbook yesterday. So this is 1 upon 1, which is 1.
And the slope.
Huh? What's the other way we can evaluate tangent of an angle?
The cosine over the sine.
You guys keep saying sine rule and cosine rule. See that sine rule and cosine rule is from fifth form and fourth form, right? Fourth? Right. Although it's just to assist you in solving sides and angles in a triangle, right? In a non-right triangle. So it's not sine rule and cosine rule, but it's one of them upon the other. Which one is it? Which one is on top? Right. So, sine upon cosine. You have to say that 15 times. Tangent of a house is equal to sine of that house upon cosine of that house. Tangent of 70 degrees is equal to sine of 70 degrees upon cosine of 70 degrees. Tangent of 45 degrees is equal to sine of 45 degrees upon cosine of 45 degrees. Guys, don't allow that to prevent you from getting 2 or 3 marks in the exam. They use it a lot. You know? Yes, just do. It might be easy because you said 15 times already. You know? I had to say it 30 times again. Right? So, sine of 45 degrees. You realize that was 1 upon root 2. And cosine of 45 was in fact 1 upon root 2 just the same. If you treat this fraction as a single thing, 1 upon root 2 divided by 1 upon root 2, something divided by that same thing, isn't that 1? Whichever way you want to treat it. Whether you want to treat it as 1 upon root 2 divided by 1 upon root 2, and that says keep the first fraction, multiply, change the division to multiplication, and flip the second fraction or find the reciprocal of the second one, and then you multiply through root 2 times root 2 is root 2. Root 2 times 1 is still root 2. Root 2 cancel root 2. Or root 2 goes into root 2 one time. 1 is the answer. Whichever way you want to do it, we'll come back on to 1. Fair enough? Alright. So that was very important. The next thing I want to do is the 30-60 degrees standard triangle. We're going to revisit these standard triangles once we do radian measure by radian. Just fair enough? Then I erase out this. Or just erase the one here. (30°, 60°) standard triangle. I don't know if it's me or it's just the heat. The heat affecting you guys. You guys look like you want to just go back home and sleep.
So I can handle it.
Okay, or something else like you guys would need a board or something, right? So, I'm not so sure if you guys follow it because you're unresponsive. Okay? So you guys have to show me that you follow it. Right? Otherwise, I'll feel like I need to repeat myself over and over and we'll get nowhere. Fair enough? I look at the blank faces and then I was like, oh, you need to say that. Fair enough?
Yes.
The 30-60 degree standard triangles come from an equilateral triangle. Go right, just look. It is derived, you can never know, from an equilateral triangle. And because this was a selling point for the calculator, how can I not sell the calculator one more time? Fair enough? If I was to take up my where's the body calculator? I tell you that the calculator needs to be in our pocket, right? Where is the calculator? Oh, so everybody needs a calculator. Who have a calculator ready? To be honest.
I copy. Can I use?
Most times you will see this calculator, right? But if I was to put, oh, by the way, if you don't have a solar panel, chances are you might go in the exam and you try turning on your calculator, and this is what happens here. Fair enough? Battery dead. Yeah? If I was to, when you turn on your calculator, by the way, remember you're going to see a little tiny b in box. That means it is in decimal. Degrees, go decimal. Got it. So this is in 45 degrees. So I can type sine of 45. You see sine of 45 included there. And if I was to press enter, I will get 0.701. That's decimal. And we learned that this fraction button here, ABC, remember that, right? If you press it, it's supposed to convert it to fraction if it can be converted to a fraction. So, but it just blink and look at it. As opposed to this, when I press sine of 45 and I press equal, what you see? Root 2 upon 2. Not even 1 upon root 2, you know. The rationalized version. So when I press S to D, see change decimal? Instead of blink and look at you, you see? So that's why this calculator is so powerful, right? 30-60 degree standard triangle.
Isn't this the same as mine?
Huh? Yes, it is. That's just a female version of this, right? So, ready? Go write it. I'm not telling you. This is not the standard triangle. This is how I get to the standard triangle, right? I'm going to be drawing on some other concepts that you weren't necessarily taught in this class, right? But it's stuff that's supposed to be very intuitive. In an equilateral triangle, Teresa, what is the tell me about the equilateral triangle first of all. Let me just ask you that. What are the properties? What about the angles and what about the sides? They're all equal. So if this is x, that is x, that is x. What can I say? And the angle, because they're all equal, what do they measure?
Sorry, again.
What do they measure?
They measure
What do they all add to?
180.
All right, and how many sides? How many angles? How many internal angles? 1, 2, 3. So I have to divide that by 3 now. And 1 is to divide by 3, 60 degrees, right? So that is 60 degrees. That is 60 degrees. That is 60 degrees. I will pick it on Teresa because she's new, yeah? So your time soon come. Right? Questions. No. Everything is 60. I can now bisect or dissect. We don't use the word dissect. Dissect is in biology. Bisect an angle. You would have done construction in third form around that time. That's all? No? You guys attend different high schools and all? Yes?
With any construction, sir.
Okay, everybody did construction that nobody know, right? How would I know that nobody know it? Because every year Mr. keep writing the report. Construction is poorly done. Yeah? So this is when I bisect. When I bisect that angle, what is this side measuring? And that side is measuring 30, right? But I don't care about that side. I just want one side. No. Remember, I simply chose 1 to be my length. Yeah? Because there's an interesting property of geometric shapes. Yeah? Remember I dealt with that? These are called similar shapes. If it is that this angle is 30 degrees, that angle is 30 degrees, that angle is 60 degrees. Let's use the lengths. If that is 1, that is 2, and that can't be 3. If that is 3, that is 4, that is 5, and it's a right angle triangle. Yes? Oh, I know why you're that. Yeah? And that is now 10, and that is now 8, and that is now 6. Note that all the sides were multiplied by 2, right? When that happens, we call those similar shapes. This is also a similar shape. If this is 2, 2, 2, 2, and that is 12, 12, 12, 12. You know? Yes? The interesting thing about similar shapes is that the angles remain the same, the internal angles. So if that was 90 and they are similar shape, the angles remain the same. Fair enough? Likewise this. If this was 30 degrees and that was 60 degrees, that means that angle is going to be 60 degrees and that is going to remain 30 degrees. That's the interesting thing. The angles remain the same, but the sides are a multiple of each other. Fair enough? Corresponding sides, that is. No. And I say that to say, whether this is x or an x or 1 and 1, the angles would remain the same, so it would still be 45. Right? Because these sides would be, I would have multiplied everything by x. This would have been x, that would have been x, and that would have been x root 2. Yeah? And if you never believe me, if this is x randomly, and that was x, so it should have been x squared, and x squared equal to, if I call that a, this would have been a squared. Fair enough? This would have been 2x squared, because this is the same thing being added. That's all. And I'm taking the square root of both of them, and that would have been the root of 2 in x squared. That's all. And now the camera, or let's put this here, 2x squared. You can learn that under the root sign, when it's multiplication and division, they can be split like that. And what's the root of x squared? The second root cancel the power of 2. Remember that? So this is just root 2 times x, which is x root 2. So you see, it appears like I just multiply everything by x. Yeah? Well, I digress a little bit. Yeah? What is important? Being able to swap this one, write it back on the paper. Know that this is 45, that is 45, and I choose the side to be 1 on 1. By Pythagoras, I would have evaluated this to be root 2. Then I can read off my sine, cosine, and tan. I can tell you everything about the angle 45. That is important, right? In exact answers. Or you can just pick up your fancy calculator and you tell them what it was. Fair enough? Good. Now for the equilateral triangle. Because we have similar shapes, you don't need to be able to tell them why it works. You just need to say, all right, I can choose random lengths, right? But it must adhere to what an equilateral triangle is supposed to be. That means, if I randomly choose this to be 1, that means because the equilateral, they are all going to be 1, right? And that's a reasonable guess, because I chose 1 over here. So I'll choose 1 over here. Not right. You know? Now, if I bisect that angle, what will I do to this length? I would also cut it in 2. And I will get 0.5 and 0.5, or a half. There's 2 things wrong with that. You can hear me say, until exam time, I do not work in decimals. Yeah? And you should not work in decimals either. So because I don't want a decimal, and it's only because of that, I'm not going to choose 1. How many pieces am I splitting this into? 2. So what's a nice number to use? 2. So if I choose 2 here, choose 2 here, and choose 2 here, this is now 1, and that is now 1. Yes? Yes. So I have nice 4 numbers working here. That makes sense. And because I have that now, I will have 30 degrees here, 60 degrees here. Note that because this was a plumb line. In physics, when I say drop a plumb line, what is important? What angle does that plumb line form with the floor? 90. A 90 degrees. Sorry, that's 90 degrees. So all of those concepts come together, right? This is now 2, that is now 1. What do I use to complete the size of a right triangle? To solve for unknown size of a right triangle. You can use sine, cosine, and tangent, but I don't want that. I want the one Pythagoras' theorem. Yeah? And what Pythagoras' theorem says? Pythagoras' theorem says a squared equal to b squared plus c squared, where a is what? The hypotenuse. It only works when it's the hypotenuse. What's the hypotenuse here? So that is 2 squared equal to so. Well, I can randomly call that b, and I can randomly call that c. Fair enough? Yes? But most times, guys, unknown is just depicted by x. So I just know that the other 2 sides are these, right? So this is going to be x squared plus 1 squared. It's always the square of whatever they are. Fair enough? So I get 4 equal to x squared plus 1. So this is thrice equal to x squared. Yes? I went through this last week. What does it mean to solve for x? It means that x must be on one side of the equation by itself. First and foremost. So because 1 was there with it, I took over the 1 because I want this side solely for x. And to bring it over the equal sign, as they like to say, you change sign from plus to minus. And because 4 minus 1 equals 3. But this is not yet the subject of the formula, because it is raised to something. is raised to a power 2. How do I get rid of a power 2? I find the root to that power, right? So I need to find the square root of both sides. Root 3 equal to x. Again, why did I not say plus or minus, which is most correct?
Length cannot be negative.
Length can't be negative. I can't say the room measure negative 3 foot. You may ask me if I'm mad. Fair enough? Alright. So I just take the positive root, and that's the answer. Yeah? So, in essence, I get root 3 here. Yes? And most importantly, that is a exact answer. And I believe it is 1.7. You get person root 3 in the calculator. 1.732. And some whole decimals behind it. Fair enough? And most times we would just write 1.732, which is not the exact answer because we would have inherently rounded off. Fair enough? So that is important. We're going to go through a similar process. You are going to go through a similar process in 3 minutes to tell me what is sine of 30, cosine of 30, tangent of 30, sine, cosine, and tangent of 60 degrees. That is 6 things in 3 minutes. Let us see how quickly we can get that done. Fair enough? So this is sine 30 degrees, cosine 30 degrees, tangent 30 degrees, sine 60 degrees, cosine 60 degrees, and tangent of 60 degrees. That makes sense? Not making sense until you tell me the answer. You already? I just wanted to confirm at least one of them with your calculator. If you do a fancy calculators, to just see if it actually works. Right. Fair enough? No. If they say exact answers and you see sine, cosine, tangent, it means more than likely you should use standard triangle. No whistling. Yeah? So everybody think they can generate this 45 degree standard triangle and 30-60 degree standard triangle if they need to, right? Generating it is not the whole answer. Using it. And what do I mean by using it? Being able to write down these stuff. Yes? Go you finish? If you try to use that black calculator, it will fail you. Yes? It won't give you exact answer. It will give you the decimal version of it. Yeah? Alright, so I believe 3 minutes has passed. 30 degrees. So, because I'm finding 30 degrees, then I must say, hey, we should understand the triangle this come from. I have two options, 45 degrees standard triangle, which the only other angle in that 45 degrees is another 45. So that one is up. We should understand the triangle, no? the 30-60 degrees standard triangle. That means I must use that, you know, to tell me stuff about 30 degrees and 60 degrees. And by the way, these are called standard angles. Standard angles are 45 degrees, 30 degrees, 60 degrees. And you have some other angles that will be popular angles. Fair enough? No. Standard angles will be used right throughout the exam because the man expect those angles to give you nice results. Fair enough? So you can see why they are important. They can come knock. Yeah, they can come on module exam, they can come on the final exam. Yes? No. 30 degrees, sine of 30. I must first remember that sine is opposite of an hypotenuse. And how do I remember that? Soccer. Yeah? All the time. You're not too big to remember this. Remember I tell you. Yeah? Don't play hero. So, sine is opposite of an hypotenuse. So I put more than 30, that's how I use it. So having derived the standard triangle, yeah? Put more than the 30 and say, what is the opposite to 30? 1. What is the hypotenuse? So if I plug in sine of 30 in whichever calculator, even that black one, I'm going to get 0.5 or a half, right? Cosine of 30, I need to put more than 30 and say what is the adjacent side? What sits beside my angle? Well, the 2 and the root 3 sit beside my angle, but 2 is already a designated thing, the hypotenuse. Yes? Therefore, root 3 is my adjacent side. Adjacent of an hypotenuse. Cosine adjacent of an hypotenuse. Root 3 and the hypotenuse is 2. Root 3 upon 2. I want everybody to type in cosine of 30 in whichever calculator, or you can type in root 3 upon 2. That decimal is supposed to be recognizable. 0.866. That's all?
So that's not recognizable at all.
No man. What? You better be recognizable to you know, just like 0.707. Yeah? You must know that possibly that is root 2. That's all? Root 2 upon 2 that is. Yes? So you got that 0.866 and so whole bunch of numbers behind it. So a lot of numbers behind it. Tangent of 30 degrees. Similarly, I'm going to put mine on the 30 and say, hey, what is tangent? Tangent is opposite of an adjacent. So I put mine on the 30 and say opposite is 1. And the adjacent side is root 3. Again, you will learn that root 3 in the denominator is not as accessible. Yeah, I think. And I will explain all of that in our class. Fair enough? So this is going to be multiply the top by root 3 and the bottom by root 3. Eventually, you can get root 3 upon 3. You can confirm. Fair enough? No. You can put that in the calculator and see what that is as well. Fair enough? No. Sine of 60. Again, it's going to be opposite of an hypotenuse. However, this time, I will require to put my finger on 60 degrees and say, what is opposite? Opposite is root 3. Guys, you see how slow I'm going through these things? Because these things are foundation. So later on, when I start talking to them and referring to them very quickly, I would have expected that you'd have gone home and studied 15 times before. Yeah? So I'm talking to somebody who is on the same page with me. You know? So this is going to be root 3 because that's the opposite of 60 upon the hypotenuse, which remains 2. Root 3 upon 2. What on that board is also equal to root 3 upon 2?
Cos 30.
Cos 30. And why is that? I alluded to it last week, so I expected you'd have heard it in class first and foremost. But in class, things can go over your head. But you'd have also watched the video on my recommendation, although you were in class, and you have heard it again. What makes sine of 60 equal to cosine of 30? What concept? Let me show another board. Yeah? Cosine of 45 and sine of 45 are also equal to each other. What makes them equal? They are complementary angles. They add to 90 degrees. See that? 30 and 60 add to 90 degrees. That means if I find the cosine and the sine of either of them, in whichever way, they're going to be equal. You know? That means if I tell you what the answer is for sine of 20, what will you tell me that is equal to? Sine of what? I mean cosine of what? 17. Remember, sine 20 is not equal to sine of 20. Eh? It's the sine and the cosine that are equal. You know? So without you plugging this in the calculator, what do you expect this to be equal to?
It will be equal to sine 30.
That means it's supposed to be equal to a half, right? Let's check. Adjacent upon hypotenuse. Put my hand on the 60. The adjacent side is 1. Upon the hypotenuse, which is? So I never tell any lies. You know? Not yet at least. Tangent of 60 degrees is opposite upon adjacent to 1. So, what's the opposite of that 60? Again, guys, don't play here and just eyeball the thing. Put your finger on it and say opposite root 3 upon the adjacent side. What is any number divided by 1? And that is an acceptable thing because it was not in the denominator. You know? Alright, so that's what we use. And I'm going to go and write them down 15 times because you can't really study. You have to write them down. Being able to write down the standard triangle, the 30-degree standard triangle and using it. Being able to write down the 45-degree standard triangle and using it. Being able to comfortably use your fancy calculator to evaluate them. And understanding how to convert them to decimal if required. You know? Both are required. So you can't say, oh, I invested in my pink calculator, therefore I don't need to know my standard triangle. No, you have to know both of them. Fair enough? Application sometimes it might not come exactly like this. They might put it in a way that you are required to use the concept, right? Radial measure. Radial measure is not explicitly on the syllabus again, but it is required. It was done in additional maths, but nobody here did additional maths. That Mr. K claimed to be a prerequisite. Fair enough? It's a useful thing to do before it, but it's not a mandatory thing. Fair enough? And it's not assumed that you didn't either. Fair enough? Radial measure. Radial measure is also called, anybody know? So I guess I have no additional mathematics students here. Yes? It's called circular measure. Remember, guys, when do you know that you don't study? When you look at the front of the class, as in, and you see the topics written down, and you can talk to yourself in your head and tell yourself exactly what is in that topic. Yeah? Or you can go to somebody and have a general conversation about pizza. You know? Without your book. That's how you know you don't study. You know? No. Radian measure, we can go back even before third part. In naming part of a circle. You know? Those competitive.
Alright, basic.
The outer, the circle itself. But this is not, this is like, you know, the center is an imaginary part of the circle, right? It's really the circumference, right? But this is the circumference. And this is the center. Yeah? And a line connecting the center O, to the circumference is called a radius. Plural radii. Yeah? Two radii makes a what?
A sector.
So a sector is formed by two radii and a. Don't lie to me.
Chord.
Don't lie to me.
Arc.
Arc. Yes? A line connecting two parts of the circumference without passing through the center is called the
Chord.
This is the major, this is the minor sector, the one with the acute angle, and the one with the reflex angle, reflex, greater than 180 degrees, but less than 360. Yeah? It's called the major sector. Yeah? We will have a what? What is this? So this is a chord. But what is inside? Segment. No? We have a minor segment and a major segment. So, that makes sense? Let's pick one bit. Yeah? No. What's the radian? Because I did all of this just to define the radian. Fair enough? Yeah. What's the radian? If I drew a circle, a center, and I constructed an arc, not an arc, a sector, yeah, such that the radius there and the radius there is equal to the length of my arc. the angle subtended at the center, the angle formed at the center, is called theta, where theta is 1 radian. Angles weren't originally measured in degrees, by the way. That's a Western thing. That seems to have some beauty. Yes? It's a very useful measure, so much so that we have adapted it. That's all. However, we're going to go back to basics with radian because it has many more applications. You know? So how do I find form a radian again? If a sector is formed, all right, by 2 radii such that the length of the arc equals is equal to the radius or the length of the radius the angle subtended are formed at the center is equal to 1 radian. So if somebody asks me to define what the radian is, radian is the angle subtended at the center when a sector is formed by 2 radii such that the length of the arc is equal to the radius. Yeah? Am I going to use this? Not necessarily. You'd have used it in additional maths. It was previously on the syllabus prior to 2012. Fair enough? There are 3 formulas that you would have used in the topic called radian measure circular measure. Right? I will just put them on the board so that you're aware of it. Fair enough? Oftentimes, the length of the arc is referred to as L. Yeah? So, length of arc is equal to L, and that is evaluated by R theta. This formula only works where theta is in radian. Alright? So if it's just in degrees and you're stuck in degrees, there's no way for you to pick up the length of the arc just like that. There is a way though. So where you can determine the length of the arc, right? By finding the total circumference. Yeah? 2 pi r, that's all. And then find what fraction of the. So if this is say 70 degrees or 60 degrees, then it should have been 60 degrees upon 360 degrees, right? In other words, what fraction of the surface is this? Yeah? And if you found that that was 1/6, then it would be 1/6 of the total circumference to find the length of the arc, right? But this simple formula magically just gives you the answer. Fair enough? Good. Note that it's only when it's in radian that that's applicable. Fair enough? Huh?
I'm nothing to say. I was recalling something from physics. Because that's what I said.
Huh?
Something from physics also fascinating.
Alright, keep that physics to yourself.
Sir,
Okay.
AC on the second hour, what do you mean?
Easy or no? I guess technician is here. Alright. So, the area of a sector, area of a sector, area measure.
Theta over 360 times.
That's the only thing you could say after that, right? But that is the same concept where I find what fraction of the surface is sector, yeah? By putting this degree over the total angle of 360. Yeah, that's what it basically did, right? Find what fraction it was, you know? And then find the total area by pi r squared. That's all. Correct?
Yes.
And that's what you did in physics. That's why mathematics is more powerful. All right, cool. So, but you'd have learned that in second form. You should have learned that in second. You know? The area of the sector is, for me, it's a key of students, is a half r squared theta, where theta is in radian. Okay? Everybody understand both concepts, right? This one is, you have to just take, you have to just try it, right? You have to try to put it in radian, and but you don't even know what the total circle measure in radian is. Fair enough? So that's, you know, again, it's a brick wall. Fair enough? Area of segment. I should show you what's happening here, the quick picture, right? Quick picture for They give you R, and they tell you, hey, this is theta. Find what that L is, and that L is R times theta. That's what they say. Fair enough? So if this was 120 degrees, you cannot say R is 2 centimeters, so it's 2 times 120 degrees. You're not going to get a unit in centimeters, right? So the field, you have to convert that 120 to radian, and there's a way to do that. Fair enough? We'll get into that. Area of a sector, note that this is area of a sector, that is R, that is R, that is theta, and the sector is all that. Fair enough? Area of sector, them say, is a half times the R squared, and then multiply by whatever the theta is. And you're supposed to get it. Fair enough? If theta is in radian only. Fair enough? Area of segment. What's a segment again? You have a 2 radii. You have a theta in the middle. Yes? But it's this. This is what they're really asking you for. That's all. That's a segment. Fair enough? Area of that shaded region. That's all. And here, notice that the only thing related is these two that are from radian measure. Fair enough? This is an application of radian measure. If they ask to find a segment. What do I know? Well, I know that the radian measure can give me the area of a sector. Yes? The area of sector is this part, including this triangle. Oh, no. So we did triangles before. Yeah, so we can find the area of a triangle. You remember that? But it's a non-right triangle. It can be a right triangle, but it's a non-right triangle. If it's not drawn to scale and we don't know what that angle is, right? Fair enough? What's the area of a non-right triangle again? That was studied 15 times.
Half base squared.
Half
Perpendicular.
base times perpendicular height. But do I know that height? No. So that is out, right? Good. What else do I know? So if half base times perpendicular height don't work, What do I need? R. R squared. It looks just like this. That's the beauty of it. Right? Let me show you. A, B, C, little a, little d. You agree? This is C. A equal a half A B sine C. Hold on. A, B, and C is the included angle of A and B. You know? Right. It's the angle formed by these two sides A and B. Let's see if we can apply it here. If I wanted to find the area of that entire sector, yes? Oh, sorry, this triangle is going to be, well, before I reach there, the area of the segment, would you agree that is area of sector minus area of triangle? Do you agree? If I take the entire sector, all of that, and then I cut over the triangle, would I not be left with the area of the segment?
Yeah.
Yes? So, what's the area of a sector? Well, Pythagoras, radian measure dictates that it's a half r squared theta if theta is in radius. Minus, hold on, a half. Let us say that that is r and that is r, and that is now my theta. Fair enough? Then it would have been a half. What is A? R. What is B? R. What is C? Well, that is a sine of theta. So it's a half r squared sine theta. You see what the formula I'm looking for here?
Still working in rads. There's a
Radian, yes. That means you couldn't just, if you're given radian, you can't just pick up your calculator and type in sine of pi upon 3. If I tell you that pi upon 3 is an angle in radians, when your calculator have a little box up top that says D, because that means degrees. In order to plug in sine of an angle in radian, you need to see a box with R, which means radian. Fair enough? Later on, we're going to figure out how on earth we get that calculator to now move from degree mode to radian. Fair enough? So that's all you would have learned in radian measure, and then I would have given you 25 questions on a worksheet, and that is it, the topic. Fair enough? That would have been your additional maths course in radian measure, circular measure. Fair enough? We are for that? Yes. Good. And if I move too fast, just go and watch the video. Yeah? And replay it and stop it and replay it again. Fair enough? Good. May I erase all of this?
Sorry, erase the right side.
Alright, low is still right. You just disobey and right and I feel that's right. Eh?
No, sir, I was listening.
You're listening. Do I need to have sleepless nights over this? No, not necessarily. I'll show you what they really need to have sleepless nights over. Okay. I don't know what Mr. Cape can bring and how they can bring the question for you to be able to use that concept because it's really accurate, right? However, based on my experience, I've not seen them bring it back since 2012 like that. Fair enough? At all. We have to use those formulas at all. Fair enough?
Right.
Yeah, like this. Alright. So I know Lorian wondering, so why on earth are you teaching me this? Right? Because we're going to use that concept. Or we're going to use the concept of radian right through. So I would believe that you need to know where radian really comes from. Fair enough? This is why I introduced this topic in your talk. I know. All right. Good chief. Hello, I take it that you're finished with this side. Right?
Yeah.
And you finished with that side too? Hmm? But it's three things to remember, right? So it should be reasonable, right? You can go and review the video and you can study 15 times and it should be within your mind, right? And it's an ongoing process. You study it now and by December you need to review it again. Fair enough? This is the most important part of radian measure that I'm putting in a box. Put it in a colorful box, a purple box, a pink box, any box. But when you open your book, it must pop out that way. Fair enough? 180 degrees equal pi radians. Some teachers will tell you to study 360 degrees equal 2 pi radians, but you realize I just multiplied the equation by 2, right? So I'm just going to put one on the board and study that 2 times. 360 degrees is really 2 pi, so 180 degrees is equal to pi radians. We need to say that 15 times. You need to remember. Wake up in the middle of the night, starting from tonight, you must, and I said, 180 degrees equal what in radians? So most people tell me, pi radians. Hear it out? Can be important to know. Mr. Kate does in fact give you questions in degrees still, right? But sometimes they give me in radians. And we need to be able to use it. Because we know our formula that have radians and degrees, that's like having a formula with x and y. And I can use the value of x to find the value of y. Now, if it is that I have degrees, can I not use this relation, yeah, to find what that angle is in radians? So there's a subtopic called converting degrees to radian. And you don't need to follow my method, but I'm going to suggest a method, right? I know that everybody can solve simple equation, right? Linear equation. But I'm going to suggest to you that if I'm converting from degrees to radian, anything that I'm converting from anything that I don't like that tense, let's switch it around. Find out what is one of anything that I am converting from, first and foremost. So anything that I'm converting from, I must find out what is one of that. Fair enough? If I'm converting from radians to degrees, because I'm just curious and I don't like radians, I just want to work in degrees and the man give me radians. I want to convert it to degrees so I can use my standard triangles in degrees because that's what I'm comfortable with. Right? I must find out first what is 1 radian. Yes? If it is that the man give me degrees and I know that I just want to work in radians, I can convert from degrees to radians. That means I need to find out what is 1 degree first, right? Anything that I'm converting from. So let us see how we get along with these things, right? First, I'm going to write down the standard angles. Everything about the standard angles we must know. Fair enough? We must know sine, cosine, and tangent in the standard angles. In exact values, right? So we must know what the standard angles are in radians as well. So we can recognize them. But not only that, I want to know what is 90, 180, 270, and 360 degrees. What's the relation between 90, 180, 270, and 360? Difference of 90. So I start with 90, go up by 90, go by another 90, go by another 90. So that means I'm adding 90 degrees to each of them. Right? That's important, you know. That's another way of finding out what 180 can be. Fair enough? If I know what 90 is. So I want to convert all of these. Let's go. I'm going to do the first two, and you're going to do the rest. Yes. So if I want to convert 30 degrees, first of all, I'm going to say, all right, recall the formula. 180 degrees equals pi radian. What is pi, by the way? Pick up a calculator. Pi, as you know it, is 22 upon 7. You will not use that, ever. Right? And you will not use, it's an approximation. And you will not use 3.142 unless the man them say, assume pi is equal to 3.142. Yes? They are approximations. Yeah? So what other do I use? Pi. That's an exact answer for Mr. Kate, by the way. Yeah? So, it's so much so an exact answer that is on your calculator. Take the calculators. Yeah, man, it's on. Oh. But I realized that came on starting with.
Yeah?
The first came.
Yeah, well,
we want to bring them on one guy. I bring them to around.
I need to do it now because in stage.
Alright.
And we still up against it. Yeah, man, that's okay. So, you know what we get them from one place?
Yeah, one is in the book. One is in the book too. And one is in the book too. And the extension is from the
of the class.
Sorry guys, the extension is also from the front part of the book too.
Welcome. One of the students can come back. I know number one for that.
So we go well, let me just give you this now on time. All right. All right, guys. So, on your calculator, if it is that you're using this, the pi is above times 10 to the x. What's times 10 to the x? That's what's that? Where have we ever seen this? What topic? Standard form, right? So you can write 273 in standard form at 2.73 times 10 to the 2. Yeah? Or you can write 0.273 in standard form at 2.73 times 10 to the minus what?
1.
Huh?
1.
See it? So you can put in standard form in the calculator, yes? So, right above times 10
This is pi. Yeah? So if you have a calculator, you can, when you buy the calculator, when you have a calculator, you can do. Again, above. Fair enough? So it's anything that is above the calculator button in a different color. If it's in a red color, you have to press the alpha in red. Yeah? Press the alpha in red. And if it's in orange, like the pi, you have to press shift because shift is in. It's color coded. You know? Cool. So you have to press shift on pi, or shift on that button and pi will come up. And when you press equal, you see give you a pi because this calculator is just set to give you exact answer. But you can press S to D, which is standard form to decimal. You get 3.145 something, right? Yes? And you can press it again and it changes it back to 5. Right? So that's the button I always press when I have to deal with pi in my calculator. Fair enough?
Oh. So pi is a number, right? Because I'm converting from degrees to radians. Yes? I can say 1 degree. How do I get 1 degree? I divide it through by 180. So I get 1 degree equal pi upon 180. Yeah? Radian for starters. Fair enough? And I want 30 of it. Yeah? So it's going to be 30 equal to? Well, 30 times 1, and then pi upon 180 times 30. So I multiply both sides by 30. So, and then 30, well, the zeros can cancel. 3 into itself goes 1, and 3 into 18 goes 6. So this is pi upon 6. Yes? So 30 degrees is equal to pi upon 6. What is 45 degrees? Well, some smarty pants, we're going to say, all right, sir, all right, cool. I can do this in my head, it's too slow. What do I need to divide 180 by to get 30? 6. So I divide both sides by 6. And I get pi upon 6 one time. Fair enough? I can say, what do I need to divide 180 by to get 45? That's not too clear, right? So you can go back to my method, right? That worked every day and twice on Sunday. Find what is 1 degree, and then multiply 2 by 45, both sides. Yeah? And then I'll get pi upon 4. You confirm that for homework. Fair enough? 60 degrees. Let me see you do that quickly. And tell me what it is.
Pi upon 3.
Did you do it?
In my head.
No, I want you to do it. Confirm.
So, pi upon 3. Remember, you must know these. At the back of your hand. 30, 45, and 60 are only standard angles. And I'm going to tell you that they're either pi upon 3, pi upon 4, pi upon 6. Yes? So, note that is a nice way of remembering. Fair enough? 30 is pi upon something, but it's not going to be pi upon 3. 3 and 3 don't go together. It's actually 3. So 60 and 30 kind of switch around. The 45, it looks like it's going to be pi upon 4, and then this is going to be pi upon 3. Know that 6 and 6 go over together. Yeah? That's just a suggestion. We have to. Another thing, because all of these are equal, I mean, the standard angles are either divided by 6, 4, or 3. You have to say which one is bigger. The 60. And if you divide a fraction, if you divide something by a smaller number, you get the bigger thing. So the smaller the denominator, the larger standard. You see?
And because 30 is the smallest of the angles, I need to divide by the largest thing. That makes sense? The larger the denominator, the smaller the fraction. Isn't that so? All right, cool. That's another concept that you keep close. Yeah? Another thing that will present itself are these. Very readily. Quickly tell me what is 90 degrees.
5.2.
Yeah.
5.2.
Somebody confirm. Well, you can say, all right, what do I need to get 90 from 180? I divide through by 2. So I need to divide both sides by 2 because anything I do to an equation, I need to do to both sides of the equation. Fair enough? All right. So this is pi upon 2. No, interestingly, again, well, 180 degrees is equal to pi radian because that's what you studied 15 times, right? 270 degrees.
3.2.
How did I get that? That's not nice way of doing it. I know that I'm really adding pi upon 2 plus pi upon 2. 90 plus 90, sorry. 180 plus 90 is equal to 270. Yes, that's so. Because I'm really adding 90 to this. You see how that works? A half a pi plus another half a pi is 1 whole pi. That's why I get 180 equal pi. I need to add 1 pi to a half a pi to get 270 degrees. And that's like 1.5 pi.
Yeah.
What is 1.5 in fraction? You must know that one very, very readily. 3/2. In mixed numbers, not mixed numbers, in improper fraction form. Fair enough? So that is 3/2 pi, or 3 pi upon 2. Yes? And then, how do I get 270 from, 360 from 270? I add 90, but 90 is pi upon 2, a half a pi. And I have 1.5 pi plus another half a pi is 2 pi. And that is even simpler. Fair enough? I lost you?
Yeah.
This is the most important thing right here. This is not something that is intuitive because you have to go and prove it, right? Theoretically, right? And I'm pretty sure somebody got a PhD in it. I mean, I studied 7 years just to prove that. You know? So, all you need to do is take it and study 15 times, close to your heart. 180 degrees equal pi radian. Take it as gospel. 180 degrees equal pi radian. And just keep saying it and saying it until it becomes a part of you. Then I need to be able to use it to find what is 30 degrees, 45 degrees, 60 degrees, 90 degrees, 180, 270, 360. So all I'm doing is trying to convert it to, or try to find how much radian makes 36, 45, 90, and so on, right? I was saying I need to first convert 180 degrees. 30 degrees to radian. But anytime I'm converting degrees to radians or vice versa, I need to say to myself, I need a relationship. I need an equation. Yeah? What equation must come to mind? 180 equal pi radian. Yes? No. I would first recall it because I studied 15 times. Yeah? I doubt it's on the formula sheet. I will tell you what's on the formula sheet as we go along, right? But we still don't encourage formula sheet use. So I would say, because I'm converting from degrees to radian, I need to say what is 1 degree because I'm converting from degrees. So I divide both sides by 180 because I have 180 degrees. So I divide by 180 to get 1 degree. But I did it to both sides of the equation. Yes? So this is 1 degree equal pi upon 180 radian. Follow me so far. Yes? Are you just shaking it? Alright, cool. Then I need to say, now I know what is 1 degree. So I can multiply both sides by 30. 30 times 1 degree is 30 degrees. and I multiply by 30 here, and I get 30 divided by 180. You can actually put it in the calculator. You don't need to, guys, you see how I simplify this? You do not need to do that. You left that in fifth form when you did C-set. You know? All I need to do is press 30, fraction button, 180, and press equal. It will simplify it for me. See, it give me 1/6. Your calculator is supposed to convert degrees to fractions. It's supposed to be able to work out ugly stuff like sine of 30 and sine of 60 for you. It's supposed to be able to simplify fractions. Why? Because would it be a shame to lose a mark just because you simplified incorrectly? And the calculator is there looking you. You know? So I would have simplified it and I would have gotten 1/6 times a pi, which is pi upon 6. You know? Same thing. Same process. I would have said 180 degrees or start as equal to pi. Divide through by 180, I would have gotten 180, 1 degree equal pi upon 180 radian. Clear now? By the way, that symbol here, although I don't readily use it because I think it's a waste of my time, and Mr. Kate don't really recognize that either. Clear now? You see that? It's like a degree and you're about half pi. Clear now? That's radian. Or you can just type or write rad. Clear now? Cool. Meaning radian. So whichever notation you want to use, or you can just leave that one. Alright? Cool. Now, we would have found 180 equal pi radian and divide both sides by 180 to get 1 degree equal pi upon 180. Then I need to multiply both sides by 45. 45 times 1 is 45. And 45 upon 180 times pi, 45 upon 180, I can plug it in my calculator, and my calculator will tell me that this goes into this 4 times. That's all? So I would have gotten 45 degrees equal to 1 upon 4 pi, which is pi upon 4. And that is what I wrote on. And I've gone through a similar process for homework to validate or confirm all of these. Fair enough? So for now, I'm simply saying 30 degrees is 5.6, 45 degrees is 5.4, 60 degrees is 5.3. Please, do not try to remember it and play hero, because sometimes you're going to say 30 is 5.3, because that's how your mind play tricks on you. Fair enough? Go and confirm it. Fair enough? Yes. Unless you're sure, having said it to yourself 30 times, you would have been certain of it. You can write it down with some confidence. Fair enough? Converting radians to degrees. I just show you a few of these, right? .273 radians. Convert 0.273 radians to degrees. To the nearest degree. Hold on. I don't need to tell you that, you know. Sorry. To the nearest 10th. In other words, nearest 10th means 1 decimal place, right? Here is another preaching, right? At the front of the paper of your exam, you will see one of the instructions named. Give all non-exact
numerical values to 3 significant figures, SL, or 1 decimal place in the case of angles, not any angle, angle in degree, right? So you see like how this is in radian, which is why they would have more likely presented it to you in 3 significant figures. Yes? Fair enough? Remember that is also 3 significant figures. Do you agree? We remember significant figures and stuff like that. Alright, so I need to send you a YouTube video showing you how to determine significant figures. I'll try to find a nice short one that is very effective. Fair enough? Alright? That you will also need to watch. That means somebody's homework is going to be to remind me of stuff, right? So 1, send video of significant figures and decimal places. So we're writing that down to remind me. Okay? 2, send homework from first class, right? Which is homework on sine and cosine rule. And what else? Syllabus and textbook, for those who do have the textbook. Fair enough? No. Because I'm converting to degrees, Mr. K never need to tell you to the nearest tenth or to the nearest or to 1 decimal place. They don't need to tell you. Because if it's not exact answer, meaning if it's not including root, pi, e, ln, you must give them to that amount of accuracy. Fair enough? What's the rule? If I'm first of all, to convert degrees to radians or radians to degree, I must know the formula, the relation. 180 degrees equals pi radian. What am I converting from, Lorian? So I need to find 1 of what? So I need to divide both sides by pi. Fair enough? So that is 1 radian equal 180 upon pi. Then I need to do what? How much of it am I finding? How much radians am I finding? 0.273. So I just multiply both sides by 0.273. Pick up your calculator, and then what that is. I want to do it, and you're going to confirm what it is. You know? Yes, that's what you got. But that's not the answer. Why? Because the one them said to an accuracy of what? Remember, this is 10, 100, thousands, 1 decimal place, 2 decimal place, 3 decimal place. Right? But significant figures, you usually start counting from the first non-zero. So this is 1 significant figure, 2 significant figure, 3 significant figure. It's just coincidental that 1 decimal place is 3 significant figures. Fair enough? Yes?
Yeah, man, yes.
So how do I round off to 1 decimal place? It's simple. So the first thing in the exam I need to recognize that one. I'm talking about angles in degrees. And angles in degrees must be to 1 decimal place according to the front of the paper that nobody reads. You know? So the first thing I need to do is identify the first decimal place by underlining it. You know so? And then I look to the right and I say, is that number greater than 5? No. So I leave it as it is. So the answer is going to be 15.6 degrees. And you put in bracket 1 BP, meaning 1 decimal place. You know? If I set to round that to 3 significant figures, what would that answer be? I would have to say, all right, what's the first non-zero value? It could be 1. Oh, hold on, I still count that? Yes, because once I start counting, I don't start counting. And I don't skip out anything for significant figures. 1, 2, 3. So that's the third significant figure. Although it's the second decimal place. I look to the right. What is to the right? Something greater than 5. That means I need to add 1 to this. So this is 1.0, and I add 1 to 2 to get, and I put in bracket the accuracy. SF means significant figures. That's it. And that's what the video going to say when somebody reminds me. Yes? All right. So Laura, anything you'll be able to convert radians to degrees? Let's give you one for yourself. Convert 5 pi upon 12 radians to degrees. Most times, once you see the pi, you know it's in radians. Fair enough? That's yours?
No.
No. That's in a minute. So just touching Cape. Fair enough? These are all Cape stuff. Right? Ready? You see 165, by the way, and it's in a fraction. Chances are it's going to be equal to a nice whole number in degrees. Fair enough? And that's an exact value. Coming from another example. Fair enough? Alrighty. So the answer. Anybody got the time as yet? Who did it? Still working on it? I'll give you 30 more seconds.
Nobody yet? Alright, let's do this in a systematic way again. Guys, I will propose a way today because I know that the algebra of things can sometimes get better of us. We know the concept, but we can't translate it to an answer. Yeah? Which is why I'm suggesting ways of doing it, right? Oh. So I'm going to have 180 degrees equal to pi radian. That's the first. Yes? But because I'm converting from radians, I need to find what is 1 radian. So if I divide through by pi, pi divided by pi is 1. And 180 degrees divided by pi. Fair enough? Then I need to multiply both sides by 5 pi upon 12. Why? Because I want to find out what is 5 pi upon 12 radians. That is correct. So let's confirm it. 180 degrees equal to pi times 5 pi upon 12. And yes, if it is that you have your fancy calculator, you can even plug everything like that, just like that, in it. Yes? Let me type it in and show you how it would look. If you have a fancy calculator, it would look just like this. You see exactly how I write on the board is exactly how it would look, which is why it's called natural view. Yes? You see? So you can't make no errors. You know? No errors. No potential errors. Exactly what I write on the board is exactly how it looks. So when I press equal, I am certain that there's no bomb dash, stem dash, or the operation problem. You know? Yes. That will be done on a Saturday, right? But we'll do all of operations to be done. Fair enough? Don't worry about that. And it's just when we do search, by the way. That's what we'll be doing. Right? So you can expect to see it. Right? So when I press equal, I get it. So it would look exactly how I put it on the board. You see? So I'll get 75 degrees. That making sense? Equal to so I work that out, it will be 75 degrees equal to 5 pi upon 12. If I may just take 30 seconds to go through this thing. Those who have this calculator, put their hands. Alright. So here's what I'm going to do. Where did the person who got the calculator last? You got, where did you get it?
Yeah.
You got it in York Pharmacy. But York had a stockpile, right? Alright. I know that Portmore had it. So what I'll do, if you're interested, I'll try to source the calculator, and then I'll just get it once, and then you guys will get it. Fair enough? Again, somebody have to remind me. Like last year, person reminded me like 7 times. Right? But you have to just be persistent and remind me, and I will get it eventually. Fair enough? Alright?
What plays in important right?
No. I mean, I remember things from the other class that
somebody was from Portmore. But I will tell you, I will send it in the group once I find it, right? So, because you realize it's two fractions, you start out with a fraction button. By pressing the fraction button. Oh, because your calculator is in STAT. Hold on, it's a different mode. Oh, cool. And when you look at this, it's in math mode.
What is there?
So you have to learn to reset your calculator to factory mode. So that's another thing you need to know, right? If it's a black calculator, shift, clear, enter will read. Shift,
Oh, never mind.
clear. So you shift. That's the only. So that's why I press shift to get it clear because it's in a different color. See how that works? And then you'll see 1, 2, 3. 3 mean all. Press 3 and press equal. And you see a black line, it means it's in factory mode, right?
I did it already.
All right, so you did it already. Cool.
But not like that.
For this, no, because a different calculator. So you see, clear is above 9. Shift, clear. Shift the clear because it's above 9, and you'll see 1 for setup, 2 for memory, 3 for all. I'll press 3, and it will say equal if I want to say yes. I will say AC if I want no, right? If I don't really want to change it. So I will press yes for 1. That means just press equal, and reset all. Press any key for AC, and it's gone. Now it's in regular. So if anything else that was on it, it will just go to math and D. That's factory setting. You know? That's the setting that works best for us. You know? Cool. All right. And that's why everybody has the same calculator, because I can't teach you any other calculator. You know? All right. So that's pretty much it. Yeah, for introductory stuff. Now we're going to deal with more important stuff. The graphs of sine, cosine, and tangent, which looks like. Let me not introduce it. Let's give you some homework. And next class, what we will be doing. So what I want you to do for next class, yes? Is number 1. Would have gone how many Saturday classes? This would have been the second? No. So you have to watch these 2 classes. The one before you watch this one. Clear enough? And then before you come here next week Saturday with a new book, separate book from that one, clear enough? You're going to have how many classes on Saturday? All right, 2 and 2. So you watch those 2 videos, right? And then you have to do all the homework, which is not a lot. Clear enough? In addition to watching the videos, so that's like 10 hours that you have to commit to. Clear enough? 2.5 hours each. You will have to read chapter 9. I know some of you don't have the book as yet. Therefore, I will give you a soft copy. As I said, it's not for sale. There's copyright implication. Who you got the book from? If somebody asks you, I don't know. Found it on the phone. I will deny it. Right? Cool. I'm just saying it straight up. All right. But I'll share it with you nonetheless. All right. So you will read chapter 9. I will even tell you to read beyond a particular page, That is page 212 to 220, right? You'll watch Saturday videos. What the days for Saturday? It was September 2nd. Remind me. And then September, when again? No, third was a Sunday.
That's Saturday.
Yeah. Yesterday.
Nine. That is Saturday. We're so slow, put us at 7, right? So, and then for the Sunday classes, you will watch September 3rd and September 10th, right? Know that you have to watch them in that order. Although they'll be posted 2nd, 3rd, right? Because this one is completely unrelated to that one. Fair enough? And take notes in separate book. Cannot stress it enough, right? 2. Sine and cosine rule handout, worksheet. To be sent. That means to be right, to remind me, right? Read. I'm pretty sure chapter 1 was, well, for today's class. Let's deal with Saturday class on Saturday, right? Read chapter 9. Read chapter 9. That is page
212.
Thank you. 212 to 220, right? It's 8 pages, but I tell you, you have to go move slow as heavy stuff. Fair enough? All right. But once you get them, it's gonna be simple stuff. Fair enough? It might take a while to get them, right? And that's it. So there is no number. All right, now good rest of the weekend. Good week, all right? And remember to set up.
So let's already have an class. Oh, so you're gonna have what she said? Huh? You're gonna have what she? Yeah. You want to touch up? I don't want to. See? Have what she?
Yeah, I'm going to have a drink. No, I'm sorry, I have a class after this.
Sure. All right. What do you want to go after? Well,
Alright. Starting about school tonight, right? Flashback to see what I was school at. Really, really good. Okay. But I don't have to yes. Or because the only class I remember was one point I was teaching the class teacher going to the class. Because I really understood. And I think now that I'm older, that the team is older. Because I'm older.
you don't distract that.
I just need to do much more natural. I would understand more. I went into, as you can see, I just started yesterday. I overlooked yesterday's timetable and that I was supposed to be at 12 when I was supposed to be at 8, and this is why I missed yesterday's class.
Oh, so you were here yesterday?
Yes. I came here for 12 instead of 8.
Oh.
So I missed that class. But when I listen to you, it's to see. Alright, so like I come here and even though it is a bit hard, I get into it. Would you need to I'm procrastinating because I was doing registry, right? I was doing my registration and I was thinking about looking at my work.